Come back. This is chemistry question 50 from IMAT 2015 past paper. So I will be answering this question. So this question is all about the solutions, the solute and solvent and stuff. Okay, so the question first starts off with the given data that is about the amount of the solute dissolved in the solvent. So we have a potassium nitrate, which is a solute, a salt where that is found to have solubility of 120 gram in 100 gram of water at 80 degrees Celsius. So we are given with temperature and the mass of a solute and mass of the solvent. So solvent is the water we have and the solute we have is the potassium nitrate salt. Okay, so also we are given with different temperatures. So here it mentions 80 degrees Celsius and the other one 50 gram in 100 gram of water at 25 degrees Celsius. Okay, so now what we can form is our ratios. Over here, we have the fixed given ratio from the question where 80 gram, uh, 80 degrees Celsius temperature is able to dissolve 120 gram of potassium nitrate into 100 gram of water. Okay, so 100 gram of water is able to dissolve 120 gram of potassium nitrate solute at a temperature 80 degrees Celsius. And then the next one we have is the temperature set at 25 degrees Celsius. So at 25 degrees Celsius, we have 50 gram of potassium nitrate dissolved in 100 gram of water. Okay, 100 gram of water. So this is our fixed ratio that is given from the question in the very first sentence. So now moving to the second sentence. Okay, so the second part of this question says a 50 gram of water was heated at 80 degrees Celsius and solid potassium nitrate added until the solution was just saturated. So meaning that at the 80 degree temperature, the 50 gram of water was used. Okay, so previously the question mentions 100 gram of water, so that's just the ratio. Okay, they're telling you this is the fixed ratio. This amount is dissolved in the 100 gram of water. But now here's the real experiment where a 50 gram of water is used. Okay, so at 80 degrees Celsius, solid potassium nitrate was being added constantly until it reaches a point where the solution is saturated. So saturated solution means it has reached to the point where the solvent has hold the maximum amount of solute dissolved. So any more amount of solute if you add, it will just form a visible solid, a crystal solid, or a precipitate. Okay, so meaning it cannot be dissolved anymore. The entire amount of solute has occupied in the solvent. Okay, so in the solvent and form the entire saturated solution. Okay, so now we have the different temperatures. So now at this point is where the experiment is actually about to start. So this is where the experiment is starting. So for 50 gram for 50 gram water for 50 gram water to dissolve potassium nitrate. Okay, so we're not sure about that. Okay, so but with the help of this given ratio above we can be able to determine how much exactly amount of potassium nitrate we can dissolve in this 50 gram water at a certain temperature. So now the first part that we are having is that we have 80 degrees Celsius. We are set the temperature at 80 degrees Celsius. So now we know that the ratio that the very first question that mentioned over here, from that given data, we're able to reconstruct the ratio, which mentions that 80 degrees is able to have 120 gram of potassium nitrate dissolved in 100 gram of water. So this means using that ratio, we can find out the amount of potassium nitrate to dissolve in the 50 gram of water at this certain temperature. Okay, so 120 gram of potassium nitrate that is dissolved in the 100 gram water. So using this fixed ratio, I'm I want to find out how many gram of potassium nitrate will I able will I able to dissolve in the 50 gram of water? Okay, how many potassium nitrate I can dissolve in 50 gram of water at this temperature, 80 degrees Celsius? Okay, so now to find out, as I've said, this is a ratio. Okay, so we have fixed ratio over here and we need to find the amount of potassium nitrate. So you can simply cross multiply. So 50 gram of water divided by 100 gram of water multiplied by 120 gram of potassium nitrate. So this will give me 60 gram of potassium nitrate. So now this is the missing value I found out. 60 gram of potassium nitrate can dissolve in 50 gram of water at a given temperature, 80 degrees Celsius. And now the next part of the question. So the next part of question, the third part, that says the solution was cooled to 25 degrees Celsius when solid potassium nitrate separated out to leave a saturated solution. Okay, now the uh, problem over here is that the initial temperature, which was set at 80 degrees Celsius, that had the 50 gram of water was cooled to 25 degrees Celsius. So now at 25 degrees Celsius, as there is a noticeable trend in the given ratio that was given by the very first sentence, where 80 degree dissolves this certain amount of potassium nitrate into the water. So you can see the noticeable trend that as the temperature increases, more amount of potassium nitrate, the solute is able to dissolve in the solvent water. At the same given amount of water, the amount of potassium nitrate dissolved in varies across different temperature. So increase in temperature will have more solute dissolved in solvent, so thereby forming more concentrated solution. So now what we can easily identify is that most likely the solution is going to be more like a dilute. Okay, so less amount of solute will be able to dissolve at the lower temperature. Okay, so now the temperature was cooled to 25 degrees Celsius. Okay, so it's now cooled into 25 degrees Celsius from 80 degrees Celsius. So as we constructed the ratio where 50 gram of potassium nitrate is dissolved in the 100 gram of water at a given temperature 25 degrees Celsius. So using that ratio, we can find out how much of potassium nitrate is dissolved in 50 gram of water. Okay, so 50 gram of potassium nitrate that is able to dissolve in 100 gram of water. So how much at 50 gram of water? So how much potassium nitrate I can dissolve in 50 gram of water at this temperature? So as I've mentioned about the cross multiplication, the same thing will happen over here. Just 50 gram of water divided by 100 gram of water multiplied by 50 gram of potassium nitrate. That will give me 25 gram of potassium nitrate. Okay, so this gives me a 25 gram of potassium nitrate able to dissolve in 50 gram of water at this temperature. And now moving on forward. So what we can conclude from this is that as the temperature was cooled to 25 degrees Celsius, there is some amount of potassium nitrate that are left undissolved. Okay, so we can see over here at the same volume of, at the same mass of water that we're given, which is a 50 gram of water, there must be some amount of potassium nitrate left undissolved, which is left as a solid. It's not dissolved in water. So these values that you see over here are actually the value of potassium nitrate that are dissolved in the water. Okay, so now what we must find out is that the crystallized, the crystalline solid, the crystalline solid of a potassium nitrate solid. Okay, potassium nitrate solid at 25 degrees Celsius. As the question mentions, it was cooled from 80 degrees Celsius to 25 degrees Celsius. So we have to find out the amount of potassium nitrate that was left undissolved, because we can see over here from our calculation calculation that there is decrease in the amount of potassium nitrate dissolved in the same given amount of water at a lower temperature. Okay, and decrease in temperature, so the mass of undissolved solute. Okay, so we have 60 gram of potassium nitrate subtracted from 25 grams of potassium nitrate from this 25-degree Celsius temperature. So this will give us 35 gram of solid potassium nitrate. Okay, so 60 gram of water was initial, which was set at 80 degrees Celsius. Okay, so this one is the initial, and this one was at 25 degrees Celsius, which was the final. And now what we have here is the undissolved solute, which is the 35 gram of solid potassium nitrate. Okay, so now the next part of question that mentions over here. So using this information provided in this question, what is the minimum mass of water that must now be added to the mixture of solution and solid in order to make this solid potassium nitrate redissolved at 25 degrees Celsius? So now we know that we have 35 gram of solid potassium nitrate that is left undissolved. So now we must find out the minimum amount of water at a temperature 25 degrees Celsius needed to dissolve this amount of potassium nitrate. Okay, so the minimum amount of water we need at this temperature to dissolve this amount of potassium nitrate. So now the next step, the second step is uh, the second step at 25 degrees Celsius of 15 gram water. Okay, so at 25 degrees Celsius of 50 gram of water, 35 gram of solid potassium nitrate remain undissolved, and only 25 gram of potassium nitrate is dissolved. Okay, so now this is the summary we can conclude from this calculation that 35 gram of solid potassium nitrate is undissolved solid, and only 25 gram of potassium nitrate is dissolved in the 50 gram of water at a temperature 25 degrees Celsius. So now moving to the third step, which is a water needed to dissolve 60 gram of potassium nitrate at 25 degrees Celsius. Okay, so as I've mentioned before, 60 gram of potassium nitrate is the total amount of potassium nitrate that was initially dissolved. Okay, so we know that initially at 80 degrees Celsius, we had a 60 gram of potassium nitrate that we had in the 50 gram of water, and then it was cooled down, which we had only 25 gram of potassium nitrate dissolved in this 50 gram of water. So meaning we have 60 gram of potassium nitrate as an initial amount of potassium nitrate. Okay, 60 gram as initial amount. Okay, so this means we're still at that same ratio. We're 25 at the 25-degree temperature. Okay, so 50 gram of potassium nitrate, 100 gram of water. So this is the fixed solubility that we are following, as I've mentioned before, the two-mate solubility ratio. So now, how much of how much of water needed to dissolve the entire 60 gram of potassium nitrate solute? So cross multiply, you get 120 gram of water. Okay, so this is 120 gram of water that is needed to dissolve this entire amount of 60 gram of potassium nitrate. Okay, so now the fourth step that is additional. Okay, additional water needed to dissolve the 35 gram solid. Okay, so in our previous calculation, we had 35 gram of potassium nitrate solid. Okay, so that's what we are going to find out in this question, in this part. Okay, in the fourth step, so we know that we need 120 gram of water to dissolve the entire 60 gram of potassium nitrate that was initially uh, poured at the 50 gram of water. So this means 120 gram of water minus from 50 gram of water. So this gives a 70 gram of water. Okay, we get 70 gram of water. So now the fifth step, the conclusion. So at 25 degrees Celsius at the ends. Okay, so now the main summary of this entire working is that 50 gram water. So now this entire summary is about the temperature that was set at 25 degrees Celsius. Okay, so now using 50 gram of water dissolves 25 gram of potassium nitrate, and then additional 70 gram water needed to dissolve remaining 35 gram of potassium solid. Okay, the undissolved solid that was cooled at 25 degrees Celsius. So 120 gram water in total in total needed needed to dissolve entire 60 gram of potassium nitrate at 25 degrees Celsius. So this 60 gram of potassium nitrate, as I mentioned before, this includes the 25 gram of potassium nitrate that was dissolved. Okay, that forms a saturated solution, and the other gram that we other mass of potassium nitrate that we have is 35 grams that was undissolved. The undissolved solid, okay, that we've had in this entire 60 gram of water at 25 degrees Celsius at using the 50 gram of water. Okay, so this thing is about the 50 gram water. So you need the total 120 gram of water to dissolve the entire thing, the 60 gram of potassium nitrate, which includes 25 grams dissolved and 35 gram of potassium nitrate undissolved. Okay, so the final part of this step is that so the final answer or the final step. So minimum, sorry, So minimum mass of water needed to redissolve remaining solid potassium nitrate in solution mixture is 70 gram water at 25 degrees Celsius. So now we've reached our final answer. So our final answer is we need 70 gram of water, the minimum amount of water to redissolve the solid potassium nitrate that was 35 gram of potassium nitrate solid. Okay, so the correct answer for this question is option D, which is 70 gram of water. Okay, so that's it about this question. But okay, so there's one very important thing I must mention about this that I forgot. So this working is pretty quite very long working because I wanted to show you the mechanism about how this solution and dissolving thing works with the temperature. Okay, but for the IMAT exam that I highly recommend. So in the third step, I've gone through very long cut. So in IMAT, you must use a very shortcut, okay, due to time limitation. So in this third step where we had to find out the water needed to dissolve 60 gram of potassium nitrate. So rather than finding the amount to dissolve the 60 gram of potassium nitrate at 25 degrees Celsius, what you can do is that you've already find out that when there's a decrease in temperature, there is some amount of solute that will remain undissolved in the given amount of water. Okay, so as we know, at 80 degrees Celsius, we have cooled into 25 degrees Celsius, and the amount of water was also the same. So, meaning with our calculation with a given ratio, there is a decrease in amount of potassium nitrate dissolved as well. So, what we had is there's a 25 gram of solid potassium nitrate remained undissolved, which explains the reason why there's a decrease in amount of potassium nitrate dissolved in water. So, from this step, you can go into second step directly, where you can find out the minimum amount of water needed to dissolve this 70 gram of to dissolve this 35 gram of water. So we know that at 25 degrees Celsius. Okay, so now continuing from the second step, this is the IMAT recommended step. Okay, so at 25 degrees Celsius, we know that already that 50 gram of potassium nitrate dissolves in 100 gram of water. Okay, so now I know that what I was left with when cooling from 80 degree to 25 degrees Celsius, that I was left with 35 gram of potassium nitrate. So if I'm left with this mass of potassium nitrate that has remained undissolved, I can use the cross multiplication, and this will give me 70 gram of water. Okay, so 70 gram of water is the minimum amount of water needed to dissolve this undissolved potassium nitrate. So this is the shortcut I was supposed to use, but for just this explanation, I had to use more long method to explain exactly how the mechanism is working inside this working. Okay, so this is the shortcut that you're supposed to use. Just from the first step, as soon you found out the amount of potassium nitrate that is undissolved, just plug in into this ratio of 25 degrees Celsius that was given in the question, 50 gram of potassium nitrate dissolved in 100 gram of water at this given temperature, and just plug in and you get this minimum amount of water. Okay, so the option is option D, 70 gram of water. So that's it about the question. So thank you guys for watching my video. I hope you find this video helpful. Please leave a like and subscribe to my channel. Thank you guys. Bye.